Um, Today, I'm here to talk about data products. I'll be talking about what they are, how we design them, how we implement them, and how we can govern them using automation. But first, I want to start with talking about what we all agree on, right? One good thing is, even if you're a most ardent data mesh skeptic, I think everyone agrees that data products are a good idea, including Gartner. And what we are all agreeing on are these three things. One is consumer focus. Uh, how do the consumer want to use data? To what questions do they need answered? And how do they want to consume data? Like, do they want to consume it using an API, just using SQL tables, or using some kind of a dashboard, right? And building for that. I think pretty much there is agreement on that. You need to have the consumer focus and multimodality that Jörg was talking about this morning. The second thing is applying product mindset to data. Whatever we are building, how is it relevant to business? Where is the business value at? And is this the most important thing that we could be building right now? And once I have built it, how do I sell it, even if it's internally? How do I get other people to start using my data product, right? Applying that product thinking, I think we agree on that as well. And the last one is about you need these long-lived product teams which are there to support this ecosystem of data product. We are not building these one-off projects where we assemble a team, they ingest data from SAP, they build a report, and then we start disbanding the team. And there is nobody there to support basically the report or even data products that they build, right? I think there is an agreement that we need this ecosystem of data products and a constant long-living teams aligned with the domains who are basically tending to this set of data products and maintaining them. But where we start to diverge is this notion of data products are also the architecture quantum of the mesh, which is basically saying they are the fundamental building blocks, which are independently deployable. They are they are the smallest coherent units and has a specific technical boundaries. In fact, this is not even a revolutionary idea. I think Zhamak spoke about it in the very first blog post she wrote about data mesh and data products on martinfowler.com. But somehow, as an industry, we've kind of overlooked it. I don't fully understand what the reason for that is. But I think this idea of data product as the architecture quantum is really, really important to do data management at scale and large organization, and to meet some of the goals of some of the goals that data mesh originally set out to solve. Let's actually talk about that, right? Why did data mesh emerge in the first place? As Zhamak herself told this morning, it was to address some of the complexities that we were seeing in the data ecosystem. But there were many different approaches before data mesh, right? So we had data warehouses, which was primarily about how do I take large volumes of structured data and start building reports and insights from them, right? And this worked really, really well as long as the data kind of fit nicely into these tables, columns, and rows. And then we had the data lakes, right? This was about how to do this, but also with unstructured data, like your images, click streams, JSON documents. This also worked quite well, but often in large organizations, we ran into sort of governance issues, right? And then we had data lakes on the cloud, which gave us this horizontal scaling and infinite elastic compute, right? Now, there was virtually no limit to the amount of data that I could be storing, computing, and running reports on, right? All of these approaches solved some of these technical scaling challenges really, really well. But here's the key point. None of them probably address the hardest scaling challenge of them all, which is how do we scale against this organizational complexity, right? Because at the end of the day, data and software is about humans, right? We have many different departments. They all want to use data for some different things, and they all want it at the same time. Maybe I'll ask a question to the audience this time, right? How many of you in your current organization are trying to build data products, but you find in a situation that everyone wants to consume the product that you're building, but nobody wants to own it? How many of you have been there? Yeah, right? Like, we're in good company. I think this is a very common problem that we see. And the reason is owning data in a large organization is bloody hard. Exactly because you have this many different groups. They all want the data product for different things. There is a tiny group of people who have the technical knowledge to be able to handle it, manage it at scale in a secure way, but they don't have the domain knowledge. And all of this is happening in a backdrop of constantly changing business priorities, right? That never stops. And then how do you get work done in this situation, right? And data mesh, and specifically data products, was designed exactly to tackle this sort of organizational complexity, right? And one of the reasons the book is 350 pages long, as Zamak has said this morning, is it is not about a technology or architecture. It is about an operating model. How do we want to organize our teams? How do we want them to build data products? And how do we empower them with good technology, architecture, and platform to be able to actually build and own data products, right? That not all of them are afraid and backing out from owning data products. How do you solve for that? If you're not solving for that, then I would argue we're not building data products or we're not building data meshes, right? I want to draw your attention to this beautiful insight from Dave Snowden. Dave Snowden, as many of you may know, he is a researcher who works in the area of complexity science and knowledge management. And then he had this very beautiful insight, which I think applies really well for the world of data and data product. I'll give you a moment to read it. So the Snowden says, the only way to scale a complex system is by decomposition to the lowest level of coherent granularity, and then allowing for recombination. Not repetition or aggregation, but recombination. And Snowden goes on to define what that good granularity is, right? He says, granularity at which people can make sense of things without specific technical knowledge. I think this is really the key point. So let's break it down. He talks about 3 approaches which we normally take in face of that organizational complexity that we are talking about, right? First one is aggregation, which is basically saying we build bigger and bigger things in order to serve wider and wider use cases and needs. And what happens after a point is that you end up with this huge, fragile monolith, which is very hard to change. You just change one thing here, and it breaks 10 other things. And after a point, nobody would want to even touch it, right? And this is, we commonly sort of get to this point when you're building bigger and bigger things. And the monolith starts sort of almost collapsing under its own weight. It's almost like saying we are going to solve traffic problem in a city like Tokyo by building wider and wider roads. We know that it's a bad idea. We need a fundamentally different approach to solve this sort of complexity. The second approach Snowden talks about is repetition. We also know about it as data folks, right? Which is, OK, now I don't want to change this thing because I'm afraid of breaking things for other people. What I'll do is I'll make a local copy and change this thing locally. And many people start doing the same thing. And after a while, you have a governance nightmare, right? Because after a while, you don't know which one is the original and which one is the copy anymore, right? Hey, where is our product master? But we have 10 different copies. Which one do you want, right? We often end up in this situation. The last one, Snowden says, which is really the magic sauce to tackle complexity, is recombination. Specifically, the kind of recombination where he says you want to kind of build smaller things and make it really, really easy to interconnect them. And the intuition here is that when you have smaller things which are easy to interconnect, people will find innovative ways of combining them to tackle any kind of complex use cases you may have in your organization. And because these things are small, despite trying, if one of them becomes, let's say, complex, you can just throw it away and start building new thing. Because the blast radius of that smaller component is contained. You're not affecting the entire system as a whole, right? And also because these things are small, it becomes sort of feasible to abstract away a lot of the engineering tasks you need to build them and abstract it into the platform. And you can let the people who are building these things apply their domain knowledge towards solving actual problems instead of solving the same engineering problems over and over again. I think that's the intuition behind this approach. If you're more interested in it, you can go and read up about the conniving framework that Snowden talks about. He has more scientific research and theories sort of backing it. But this is the key idea behind data products, right? So they are basically solving for organizational complexity by building smaller things and making it really easy to sort of connect them. With this in mind, let's look at some of the things which are normally sort of claimed as data products, and let's question ourselves, does it allow for this kind of recombination that we were talking about? Just a PDF report. Does it? Because I don't think it's meant, you can actually read a PDF report, send it in an email, and that's about it. It's not made for programmatic access at all. I don't think they are data products. Dashboards, right? Maybe this is the next step, but I would still argue dashboards are primary for human consumption. They are not for these AI bots, or it's not even built for programmatic access. So I don't think calling dashboards as a data product is also a good idea. I don't think they allow for this sort of recombination that we're talking about. Just a random raw table in your warehouse, right? If you're not intentional about it, if your documentation is not right, you haven't really thought about what keys that you've put in, and it is not really meant for recombination. It's just a random table which is lying out there, right? I think without that intentionality put into it, I would argue not every table in your, let's say, warehouse or a data lake is a data product. You need to be intentional about it. And the last one is, this is probably the most absurd one. I've heard arguments where entire data warehouse is a data product. It is neither the lowest level of granularity that you can build, nor is it composable. I don't think data warehouses are data products. But we said what it is not, so let's try and talk about what actually it is, right? What does it actually mean to build data product as an architecture quantum? I'd say it needs to have these sort of 5 characteristics. We'll go through each one of them one by one. The first one is they have to be self-contained. I'd say self-contained in terms of code, data, and the infrastructure provisioning that it needs to do, right? Typically, each of the data products that we build lives in its own source control repository. And that repository has the code to kind of transform your input into the output, any infrastructure it needs to provision, storage, compute, etc. Any policies, at least the local policies that apply to that particular data product, any kind of definition about the service levels, right? I think this is sort of the bare minimum you need to have to make that a complete self-contained entity. And why is this a good idea? Why do we need to do this, right? Because this is what kind of makes it feasible to kind of start identifying the blueprints and patterns and start building standard tooling around it. You need standard tooling that all the teams in your company are building data products more or less the same way. They're focused on actually the business logic and less on the engineering tasks that need to be done over and over again, right? So having a simple structure like this, you can make sure that you can build platforms to standardize the workflows around it. And also, this makes it feasible to kind of assign and reassign ownership, right? Maybe you can start with a small team who owns all of the data products that you have in your company. As the more and more use cases sort of grow, you can assign and reassign ownership, right? You can split your teams, assign ownership of certain data products to one team versus the other. And if you build it this way, it's just about handing over a repository, right? You don't have to sort of sit around and decouple like a one mono repo that you have and start making smaller things. You're already building for that. You're already building for the fact that, OK, you're going to grow your teams, you're going to split them, and at some point, you need to assign and reassign ownership of data products. The second characteristic is that they need to be independently deployable. This sort of becomes trivial if every data product has its own repository, but there are also other things, right? You need to think about backward compatibility. When you deploy it, you don't want to break your consumers, right? And this is where things like data contracts come into play. But it's very important that each of your data products are independently deployable, because this is what makes the the thing I was talking about, right? Containing the blast radius. If one of your data product kind of becomes too complex, you can throw it away and rewrite, right? And having this independent deploying capability without affecting other data products in your system is very, very important. The next one is it needs to have high functional cohesion. I think Zhamak talks about it in terms of it needs to be valuable on its own. It's the same thing. Which is a way of saying every data product needs to do one thing and one thing really, really well, right? Because this is what is kind of a test. This is what makes it whether the data product is simple enough or is it too big, right? So one of the tests I use normally is that, can you describe the job description of a data product in a simple line or two? If you need a paragraph or if you need an entire page, then it's probably not a data product. We're going to apply this thumb rule in the coming section and design some data product, but this is what it is about. So every data product needs to be highly functionally cohesive, and it needs to do one thing really, really well. And the next one is they need to be composable, right? One of the reasons why we keep using hexagons as a metaphor for data products is that hexagons sort of compose really, really well. You can kind of nicely fit them with each other. And this is key, right? This is key for overcoming that organizational complexity that I was talking about, right? The ability to build these smaller things and have them easily interconnectable using, let's say, APIs or whatever different kinds of output ports is what makes data products valuable. So they are meant for composability. You need to be able to compose them in different ways to solve for different use cases that you have in your company. And of course, like, it needs to be owned by a single team, right? One team can have multiple data products. They can own multiple data products. But it should never be the case where there is a data product, it is owned by team A, team B, team C together. I think then you can start confusing the ownership boundaries. When there's an issue, you don't know whom to talk about. And it also, like if you're building them as small architectural sort of quantums, it doesn't make sense that you're actually splitting the ownership because they are simple things. It might as well have one team owning them, right? I think these 5 things put together, for me, defines what it means to build data products as an architecture quantum. In the next section, I want to actually make that even more concrete, right? Enough of theory, let's start actually designing some data product and see how we can actually build them. So one of the key design practices we use to build data products is that we always work backwards from a use case. This is crucial to make sure that you're not over-engineering stuff, right? You're not kind of sitting there and spending 2 months on analyzing all the future use cases that you may have, for which you need to build data products. So we start with a simple use case, and we build just enough to satisfy that use case, right? Let's take this use case, which is about, it's a fashion retailing domain, and I want to have a list of all the consumers, all the customers that I have, and I need to be able to identify, assign a customer lifetime value to them so that my customer reps can target, let's say, a high-value customer and make it even more interesting for them to engage with my brand. So let's say that's the use case. You start with what we call the consumer-oriented data product. So let's imagine there is a data product called customer lifetime value, which does exactly this, right? You see those columns there. It has customer ID, and it has a predicted score, and probably it has a next best action, let's say, a customer rep can take to engage that customer. Let's imagine it already exists. Now, we can ask ourselves a question: what do I need to do in order to build this data product? So you work backwards from there. Then we arrive at, OK, I need a data product called historical purchases, which is about, OK, what are all the previous purchases that made by customer? I need a data product called returns. And I need a data product, let's say, calling customer market 360, which is marketing 360, which gives me some basic information about that customer whom I'm going to target. Let's again go back to the Snowden insight and apply this test. We said a good abstraction or good granularity is at which people can make sense of things even without specific technical knowledge. Do these data products fit that test? Can I define each one of them in a simple sentence or two? Let's try to do that, right? Customer lifetime value. It's a list of customers and a predicted CLV, customer lifetime value score for them. Historical purchases. It's a list of all the historical purchases made by a customer. Returns. It's a list of all the returns for a given customer. The data product exposes that. Customer marketing 360. It's a list of customer demographic data that I have that I could be using for marketing, right? It's easy. I don't need a paragraph to describe each of these data products. I can do it in a sentence or two, which is actually the test I was talking about, or Snowden was talking about, rather. So once you have these data products, we can work backwards again, right? So what are the system of records where the raw data for these data products lie? So, okay, I have an order service where I can get the previous orders from. I have a CRM where I can get basic information about my customer, so I need to build integration for that, right? So what we have done is we have taken a use case, worked backwards from there, and then defined what are the basic data products I need to build and what integration I need to build to make that happen. One of the common criticism I get when we do this exercise with customers, we do it in a workshop, is that, hey, we are not building data product just to serve one use case. We are building data product to solve all of the analytical use cases that I have in my system, which is fair, right? But you need to start somewhere. So we take one step further. We say, okay, that's a valid criticism. So let's take this data product portfolio that I have. Let's try to overlay this with another use case. And while doing it, our aim is that we're not just adding new data products every time. We are trying to generalize what already exists. And we are going to add a new data product only if even after trying to generalize, it doesn't satisfy my use case. Only then I'm going to introduce a new data product. Otherwise, I'll try to generalize the portfolio of the data products that I have. Let's try to do that. So the second use case I want to build is product recommendation. So let's assume, again, the same process. Let's assume there is a consumer-oriented data product called product recommendation, which is for every customer that I have in my database, it's going to generate a list of SKUs that I could be recommending to them, right? Let's imagine it exists. And there is an integration to my web shop that is taking those recommendations and pushing it live in the customer view. Now, let's test if the data product that I already have is useful for building product recommendation. One thing that I straight away noticed is that in the previous version of customer data product that I had, we didn't have a gender because it was not needed for the use case that I had at the time, which was just to calculate customer lifetime value. We didn't need gender at the time. But to be able to generate product recommendation, I need gender. So I'll add that information now to the customer marketing data product. So we are trying to generalize it to fit 2 use cases instead of just 1. I also see that we can straight up use the returns and historical purchases. So that we know their buying patterns and what they actually kept and what they actually returned. But now I also need another data product, which is list of all the products that I have, which I could be recommending, which was not there for calculating CLV. So we start building this products data product, which is just about list of all the SKUs that I could be selling, and a description around it, right? So the key point here is that we are introducing additional complexity as we introduce more use cases, additional data products. At the same time, we are trying to sort of generalize what already exists. And then we figure out, OK, to build products data product, I need to build the integration with the product service, which is fine. So I plan for that, right? So this is one way of overcoming that fear that, hey, we are not overfitting this data product for just one use case. We are not building for one use case. We need to solve multiple analytical use cases in my company, right? And what I've seen is that if you do the same exercise for, let's say, 3 or 4 use cases, most of the fundamental building blocks that you would have in your domain, you already discovered them, right? You are at a state where you can probably address 80, 90% of the use cases in that domain if you do this exercise for, let's say, 3 to 4 to, let's say, up to 5 use cases. So yeah, one picture I missed after this is, so once you have this, it kind of easier also becomes easier to have conversation around what domains these data products belong to, right? You can imagine drawing sort of circles around, groupings around these data products, saying that maybe the customer historical purchases, it belongs to the orders domain, a customer belongs to the marketing domain, products belong to your products or your procurement domain, right? So you can start kind of drawing boundaries around this and start having a conversation around which domain or which team should start owning these data products. But creating that clarity is important, right? So I cannot. So one thing I do want to emphasize here is that this design step is really, really important. You may follow a different approach, or you may want to use this approach, but it is very important to be intentional about what data products you're building. It shouldn't be the case where I connect some fancy tooling to my SAP, and it will start creating data products from every table that I have there, right? Then you'll end up in the same sort of mess that we had before, right? So you need to be super intentional about what data products you are actually creating and deciding to maintain. So what next? So we have the use cases, we have the portfolio of data product. What are we going to do with this? The next thing you can do is, now you can start identifying patterns, right? So basically, you can start seeing what are the patterns around input, right? Maybe we say that the data products are reading from S3, or it is reading from other data products, or let's say an FTP server. And then you can start seeing patterns around output, right? Every data product is writing to a data table in my S3, a data table in my, let's say, Snowflake. It's writing to an S3 bucket, and then it's also exposing an API as an output port. And then we also start seeing patterns like, OK, most of the transformation in this data product can be expressed using Spark jobs, or let's say another SQL-based transformation, right? So the key point of identifying this pattern is that then you can start to abstract those patterns into your platform. You can build a platform, basically, which makes it easy to implement those templates or blueprints, right? So basically, then the job of the platform team becomes, they just optimize for supplying those capability building blocks. Let's say in this, say they supply a Snowflake output port, they have a capability to kind of register automatically the catalog. They have a S3 output port and let's say another input port which can read from downstream data products. So they're building for that. They're building like almost like a library of capabilities that the data product teams can then use. And then the job of data product team becomes they're going to just merely use these capabilities that platform team is providing, probably in a declarative way, and then they start assembling these data products, right? And they're actually focusing on the core business logic needed to transform the input to output, right? They're not worrying about how to store data. They're not worrying about how to do access control. They're not worrying about how do I provision compute. All of that is solved for them from the platform team and provided that as a service. So with this, you have this sort of clear separation of concern between what platform team does and what product team does. This is really, really important, right? To create that, we are starting to create the specific responsibility for product team, which is serving the sort of platform team, which is serving the data product teams, and the data product team is serving the business. They're building data products which are needed to solve the high priority analytical use cases in their domain and in their company. So once you have that clear separation, right, how are they consuming that service provided by the platform? As I said, they're already doing it using a specification, right? So, or some kind of a domain-specific language in Python, or you can do it multiple different ways. So let's look at the specification, right? Like, you have sort of many different vendor tools right now, which is trying to do the same. It will have all the building blocks which are needed to actually build a data product. It has a name. What is the name of the data product? Who's the owner? Which domain does it belong to? Where is it reading data from? What are the input sources? Where is it writing data to? You can keep extending this idea. Like, what is the let's say, what are the service level I need to measure, yada, 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 right? So, and then you can imagine that it can be done using, let's say, a simple CI/CD pipeline, or you can have a middleware somewhere, or a vendor tooling, which takes such a declarative specification and doing the right thing on the platform, which is provisioning that data product. And this idea can do a lot of things, right? For example, you can take the same specification. It has all of the metadata about a lot of the, at least the static metadata about the data product, if not the runtime details, and you can start automatically register that data product to your catalog, right? So that the data product team, they don't have to individually worry about how to do that. How do I register my data product to whatever the catalog you may have, like a Purview, Collibra, Atlan, whatever that is, right? So that is taken care of. They don't need to worry about it. You can extend the same idea even for monitoring. One of the things that we do during the design phase, once we had that portfolio of data product, is we start talking about what are the service level objectives for the data product. Let's say for the consumer, for the customer CLV data product, we talk about how often the data is used, how often you are publishing campaigns using that, how fresh the data needs to be, and how accurate it needs to be, right? How accurate those predicted CLV scores need to be, right? From that, you can derive what are the measurable service level indicators that I could be measuring. And again, you just specify that declaratively in your specification. You can see here saying that, hey, I expect freshness to be measured, and this is my expectation. I expect it to be fresh at least up to 250, 240 sort of seconds. Once you have this, you can start measuring those service level indicators centrally at the platform level and publish those metrics to a central place. It could be a catalog or some sort of a data product dashboard that you have. This is really, really important, right? What you're doing here is that you're creating the transparency between the data producer and the consumer about how the service level indicators are being met. And as a data consumer, this is really important, because I'll be investing my time building on and consuming this solution. And again, it's the job of the data product owner to convince me that it's a good idea to use the product that I'm selling you or I'm providing you, right? So creating this transparency, here we are saying we calculated all the, or looked at all the SLIs, we calculated some sort of a weighted score on it, and we make it really transparent, saying that, hey, it's more or less 100% available, 75% on the consistency score, it's 100% on the freshness, and it's almost 90% complete all the time, right? So you're running those SLI measurements centrally and making that results transparent to the consumer so as to increase trust, that you want internal consumers to be building on your data product and not something else. And definitely not starting from scratch just because they cannot rely on any data that they have, right? So you want to avoid that at all costs. With that, maybe, so this goes in the direction of automated computational governance, right? So this is just one of the idea. Another idea we have used successfully is this notion of architectural fitness function test. I know it kind of sounds fancy, but fitness functions are just a special purpose test which are written to measure how a given implementation, how closely it tracks the stated design objectives, right? The idea actually comes from this book, the Evolutionary Architecture book, which is also a place where the idea of architecture quantum comes from. Neil Ford, who was there in the conference, he's one of the main authors on the book. So we discussed a lot about the architecture characteristics of data product, that it needs to be composable, it needs to have high cohesion, it needs to be have a good documentation and all that, right? So the idea behind this was, OK, can we actually write tests to measure it? Can we write tests to measure it objectively and make those results also public? So we picked, like, say, the 8 characteristics of data product. I think it was 6 at the time. And then we started thinking about what tests we could be writing in order to measure those architectural characteristics. The first one was self-describable, right? How do you measure self-describability of a data product? The very first test we wrote was to check whether every data product has a proper description in the catalog. You're checking whether it even has a description. And you can also write tests about whether each of the column that it exposes, do they have proper description. And then we extended this idea, right? These days you have LLMs which can do these things really easily. You can, if you provide it a description and the domain context, it can tell you whether it's a good description or a bad description, right? For example, a description like we said, it's a data product that exposes a list of all the customer purchases is a good one. Let's say there's a, like, you see descriptions such as, this data product joins table A to table B and has this union of all the row sets from SAP. That's a bad description. It's tautological. You're just explaining what you're doing. You're not explaining what the intention of the data product is. You're not explaining how you're supposed to use the data product. Right? You're just explaining what you're doing. You're joining X to Y, and then there's a table that came, and then that's the description. It'll be surprising how common those bad descriptions are, right? Once you start building these dashboards, once you start executing this test. The second test we wanted to write was for addressability. Every data product needs to be addressable. What does it actually mean? It means, does it have output ports, proper output ports? Or in this case, does it have a unique URI that I could be using to uniquely identify a data product in my ecosystem, right? Again, you can do the same test using the metadata of the data product. The next thing we wanted to discuss was, we wanted to test was discoverable. How to test discoverability, right? A simple test is you have a central catalog or a place where you intend data product to be discoverable, and then you issue sort of, let's say, keywords against it. So for example, if I search for customer, I expect customer 360 or customer marketing 360 to be in my top 5 results. If it is not there, then somehow it is not discoverable, right? It is getting lost in the noise. So you can also test for this, like in your whatever discoverability system. You can issue keyword-based search for all of the main topics or information concepts that you're interested in, and then see if the relevant data products actually turn up or not. Secure. The very basic test for secure is that if the data product is blocked by default, right? I was at a client where it's surprising how often this happens, right? It's just that we don't think about, sometimes we take it for granted, but I've seen instances where the data product was open for all, and it was given to like an intern, a college intern for research without proper due process. Just because it could be done and there was no sort of documentation or policies around it, right? So very basic tests like testing whether your data product is blocked by default is very, very powerful. You'll be surprised to see how many data products which actually break those policies, right? And then like the advanced test could be about it has access only if for specific roles, right? That's also something you want to automate. Trustworthy. How can you test trustworthiness? The first test, again, was simply about, do they even have published service level objectives? Are they making that transparent to their consumers? And the second level of test is about how closely they are meeting their own published service level objectives, which could be in terms of those service level indicator or weighted score that I was talking about, right? Let's say the test says that it has to be above 90%. If it's below that, then it's not fit. Interoperable. A test of interoperability could be about, do data products have the standard output port that was commonly agreed upon in my governance? Let's say we have sort of governance forum, and we agreed saying that every data product needs to have a SQL-based output port, or let's say an API-based output port. If that is the agreement, then you can test for it, saying that, hey, you have listed a data product, but it doesn't expose the standard output port that I expect, which is an API. Hence, it is less interoperable. So you can actually test for that. So once you have tests like this, you can start doing fancy things, right? You can start building dashboards, which looks like, hey, it groups all the data products by its domain, and some of them are green, which means that they passed all the fitness function tests, and some of them are red. And you can also drill down and see why it failed a test, right? In this dashboard here, you're saying that, hey, this particular data product failed addressability test because an URI was not found in Colibra or the data catalog that I would be using, right? Again, this is really, really powerful. What we are trying to do here is that we are trying to create at least soft incentives for playing by the rules. If you have a dashboard which is sort of publicly accessible within the organization, no team wants to see their data products as red, as failing. Everyone has this incentive to make sure that all the data products that they own, they're fit, they're showing as green, right? So it creates that sort of a soft incentives to make sure that each of your data product teams are actually playing by the rules, right? These are just an example of what we actually mean by automated governance, right? And all of this, hopefully you can see that hinges on this idea that data products are really these fundamental building blocks or architecture quantum of the mesh, which has specific technical boundaries, and they are simple. They're built using the same common principles, right? So once you actually embrace that idea, you can start doing all of these fancier things and automations to start imposing governance rules and standardizing the workflow of how it actually is built, so that the product teams can focus on what they're actually good at, which is how do I apply my domain knowledge to solve business problems instead of solving the same engineering problem of how to store data, compute, provision access, register it to catalog, all of those plumbing that you have to do to maintain a data product. Actually, that's all I had. So I hope you found this talk useful. So I just wanted to share some practical tips based on the work we've been doing with building data meshes over the last 5 years. Thanks for listening.
Thank you, Kiran. We have about 10 minutes for questions, so all questions you have. Oh.
Hey, so you mentioned that regarding what is data product and what is not, you mentioned the dashboards are not data products, which I agree. But couldn't we kind of consider these interfaces, in a way, human interfaces to data products? If the data product itself is self-contained set of data somewhere, but it's just exposing some of that for human users via a dashboard and something else to, machines via an API, wouldn't that still make the dashboard part of the data product?
Yeah, absolutely. I mean, I'm not saying data dashboards are useless. I'm saying the data dashboards are absolutely useful, and they should be built on top of data product. Sometimes you can think of them as even output ports of a data product if it's just built on one data product, or if it depends on multiple data products, it is not. But they're not. There is no need to call them data products. All I'm saying is that data products are the specific thing with a specific technical boundaries, and agreeing on that definition makes a lot of things easier in terms of how we build platforms, how we govern them, how we build automation around it. Once you start conflicting too many things as data product, like the dashboards are data product, data warehouse as data product, data lake is, then if everything is a data product, nothing is, right? And then you cannot achieve this sort of efficiency I was talking about, right? So that is the only intention, saying that dashboards, fine, just call them dashboards. Kafka topics, just call them events. Why do we have to label everything as data product? I don't fully understand that thing. I mean, I kind of understand, because I think because it's in the hype, and a lot of people just want to kind of ride on that hype, saying, maybe to get internal funding or whatnot, but yeah, I find it harmful actually to the discourse, at least to get that internal alignment within the organization.
Other questions?
Yeah, thanks for the explanation. I was wondering, with your 5 years of experience, if you have ever come across this. I'm working in a very distributed environment with not one customer source, but like several customer sources. And they're all put on the data mesh platform as data products. And then they are aggregated into one product. But that leads to the customer, the data consumer, not finding their way anymore in a tons of data products. Some are relevant, some are not. So if you have ever come across this, and how do we solve this problem?
Yeah, I mean, that's why I said I try to emphasize on this design step, right? You need to be intentional about what data products that you're building and owning, right? And this is where that role of data product management or domain ownership comes into play, right? If I'm the product owner of set of data products, right? I own a portfolio of data products in my domain. I'd be very, very careful about what data products that I own and providing exposing, right? It shouldn't be just in a random. Just because it's there, just because any table in your warehouse shouldn't be a data product. Then it's like, again, like it gets drowned, right? So you need to have some sort of an intentional design process, whatever you follow. Like I just showed you one approach that we've been using, which is working back from the use case with a bunch of domain expert, trying to define what data product is, refining it using definitions, and forcing people to talk about, okay, what is the purpose of this data product, right? So that's just one approach that we've been using. But you could be using whatever works in your company, but the main thing is that you need to be intentional about what data products that you're building and what data products portfolio that you're going to maintain, right? You cannot just hope that you connect some fancy tooling to your source system, which will create hundreds and thousands of data product, and it is going to be useful. I don't think that is true, at least not so far. Maybe we'll get there based on, okay, the AI agents will be intelligent enough to apply that rationale and start filtering out all the unnecessary data product, but I don't think we are there yet.
So don't you think reducing data products to quantum building blocks, as you explained, is limiting? Just like designing an iPhone has nothing to do with just adding electronic building parts together, etc. I think, in my opinion, I believe we miss a lot of the work to be done by the product owners if we think so. Because it's also, building a data product is also about abstraction, taming complexity, reducing cognitive load for the end user, etc., making it easy, in fact, in the end, for the end user to do his job. So don't you think it could be, on the long term, harmful? So I understand that you give guidelines to direct the way we build data products, but don't you think it can be harmful in the long term?
I agree with all of the things you said towards the end, which is data product needs to be maintainable, it needs to support multiple use cases, but and it needs to tackle the complex demands and the use cases you have in organization. But I also firmly believe that complexity, you can only solve for such complexity with simpler building blocks. You need to have simple building blocks and make it really easy to interconnect them, which will solve a lot of those complex use cases and usage patterns within the organization. I think that's the key insight from Snowden that I was trying to solve. And this is also, honestly, what we have learned from microservice movement, right? It is that you need to have smaller things which are easy to throw away and rebuild, and make it really, and create an ecosystem where those things can interact with each other. And this is enough to tackle any sort of complexity that you may have in your organization. Or actually, this is the only way to tackle complexities that you have in your large organization, rather, right? It's even stronger than that. But yeah, I mean, at least this has been my experience.
From a full landscape view, so this is the analytical plane going into or feeding from the operational plane. I've seen a lot of examples where they kind of define different domains at the analytical plane than exactly living on the operational plane. But from my perspective, it's from a landscape perspective, analytical or operational, those same domains are articulating, because that kind of helps you to define the ownership. And I wanted to hear your point of view on that, on how that
I 100%
looks from
agree
your
with
perspective.
I 100% agree with you, right? There is this, somehow as an industry, there's this notion of what I hear data domains, and every time I hear it, I kind of squinch, right? Because they're just domains, those are your business domains. And the whole idea behind data mesh is that you want to get this analytical and transactional plane closer within the construct of a domain, and seamlessly work together, right? If you create this artificially, this is just a data analytics domain, and this is the business domain, and this is the transactional domain, then you're not solving any problem. You're still creating those boundaries and organizing your people differently, which means that Conway's law comes into play, which is they optimize for the kind of organization that they have and start introducing artificial sort of boundaries between those teams, and we end up in the same sort of complexity, albeit with a different name. And I think there are just domains. There are just business domains. And the whole idea behind data mesh is how do I get people who are building data products and specialized in solving for analytics, and how do I get people who are building for your operational systems, and how do we get them closer towards the same common business goal, right? If you're in a customer domain, like your goal is that how do I make my customer happy? Like what kind of services that I need to be building in order to make them happy, and how can I leverage analytics to do that? Like by targeting, let's say, them with better products and giving them a better service and whatnot. How do I use analytics for it, right? Yeah, I think it should be just domains, just business domains. And every time I hear data domains, I kind of squirm a little bit. But at the same time, I think there is one merit to it, one positive to it, which is in a lot of the organizations that we work with, there is no concept of domain. They have like a monolithic, let's say an SAP or some sort of a Oracle ERP system, and they want to go towards a domain-oriented organization. In that case, you need to start somewhere. So starting on an analytical plane and using that almost like a forcing function to drive that change on your operational plane, that is a good idea. Because you don't have anything, you need to start somewhere. Maybe your analytics plane is greenfield, so it probably it's feasible to start this domain-oriented teams in your analytical plane, see how it works, see whether those boundaries make sense, and then start driving that change towards your operational system. So you're almost using this as a reverse sort of forcing function, which is a good idea.
Yeah. First of all, great presentation. It resonates with me a lot. I'm curious about what is your take about semantics. I mean, in order to make data product really reusable and composable, technical integrability is not enough. You need also to have semantic integrability.
Yep.
You know? But because data products are aligned with domains, and each business domain have its own ubiquitous language, if the semantics is owned only by the domains, you have one semantics for each domain. So basically, you have a lot of semantic silos. And the semantic and the work of doing the semantic translation to make product composable across domain, it's all upon the potential consumer. And this is a big problem to foster reusability and composability across the domain.
Yeah.
In my experience, even most successful customers that adopt the data mesh are not able to reuse product across the domain.
Yeah.
The rate of reusability across domain and composability across domain is very, very low. And for me, for a semantics reason. So what's your take about semantics?
Yeah, I think that's an excellent question. I just kind of avoided this topic because that's an entire conference talk could be on its own. But I do think that semantic layer as one of the overarching capabilities is essential just to sort of maintain that sort of consistency you were talking about. And this is where I actually like this idea from Gartner's data fabric, right? There they talk about, what do they call it? I forgot the name for it. I forgot the name for it, but the key idea they have is that, hey, once you have these data products or clean metadata, like assuming that the data products will have clean metadata, you can leverage a lot of the AI and ML capabilities to actually build or infer that semantic layer or a knowledge graph. You don't want to build it because it has the same problem that you start building something, it goes out of reality, and it is hard to maintain like the standard version of knowledge graph. But what if you can infer that knowledge graph based on the clean metadata that you have based on your data products, right? I feel that that's an excellent idea from data fabric, and we could use that same concept straight up in data mesh, right? You have data products, you have clean metadata, and you just need to build that layer where you can harvest that metadata and start inferring that semantic layer, which is the knowledge graph. Yeah, I think it's absolutely needed, and yeah, that is it should be at an overarching mesh level, not inside a domain, for sure.
Looking at the timing, one last question.
We got a quick one, I hope. You said that the data product should be valuable on its own. Do you have any experience on measuring or evaluating how well this goal is reached?
Yeah, I mean, one thumb rule I always use is that can you explain the purpose in a simple sentence or two? That's a very good test for whether it's valuable on its own. If you want a paragraph to explain what it is doing, saying that, hey, it's a customer and a product thing, and you're using and lots of preposition to join and to make a paragraph, then it's doing too much. It's not valuable on its own. You need to kind of join, either break it down or always join with something else to get something useful, right? So that's the heuristics that I've been using, which is that, hey, what is the purpose of this data product? Can you explain in a simple sentence or two? And does that make within the domain context that you're in? So it's basically about applying your domain expertise to arrive at that judgment. I haven't found a real objective way of measuring it, but yeah, this thing, again, like using an LLM to see if it's a good definition. So you can have like examples of good data products and then ask maybe an LLM to say if this description makes sense or if it's too big or too small. I mean, that's the best I've found, right? But at the end of the day, yeah, you need to apply your judgment and domain expertise to decide that. But yeah, you can apply these heuristics to see if you're in the right direction.
Let's thank Kiran again for the talk. Thank you.
Yeah, thanks a lot, Tom and DataMesh Live to give me this opportunity.